All right, Geometry Honors, I am back and I'm better than ever. Back with Unit 3, Right Triangle Trigonometry. All right, so Introduction to Right Triangle Trigonometry, solving for the missing side. So with this unit, it's all one shape and one specific shape only, a right triangle. That's all we're dealing with here, right triangles. All right, here are the four most important words you will need for this unit. Number one, theta. Please don't make fun of my lisp. Theta. All right, one of the angles of the right triangle, but not the right angle. It's also called the angle of perspective. So you can see theta's right here, and it looks like a little Pokemon egg. So there's one here, and here's one here. So when we're talking about a specific angle, theta, I need you to label it with this Pokemon egg. All right, hypotenuse, the longest side of a right triangle, and it's always right across from the right angle. All right, now we've got names for the two other sides, the legs. We've got opposite and adjacent. So opposite means across, right? So it's the side that's across from the theta. That's why it's important to label theta first, because opposite is across from it. Adjacent means right next to. So the adjacent side is the one right next to the theta. It's right next to it. What I recommend doing is labeling in this order exactly. You label your theta, your hypotenuse, your opposite, and your adjacent. You have to have theta labeled to do everything else. The hypotenuse is the easiest one to see because it's the longest side. Opposite is pretty easy to identify, and then adjacent is just your last side that's left. All right, so let's go ahead and practice by labeling the sides of these right triangles. So my theta is already labeled, so I'm going to go based on this perspective, this theta perspective. So here are the three sides that I need to label. I'm going to start with hypotenuse. It's always the longest side across from the right angle, and I'm going to abbreviate it HYP. Hype it up. I know you're laughing. All right, now let's do opposite. Opposite is on the other side, the opposite side of the theta. So right here is my opposite side. And the last side that's left is the adjacent. All right, go ahead and pause the video, and I want you to try labeling these two. Pause that video. Okay. Hopefully you've labeled, and we're just going to check and make sure your labeling was correct. So here my hypotenuse is across from the right angle. All right, my angle of perspective, my theta, is right here. So my opposite side is on this, over here. This is my opposite side, which makes this right here my adjacent side. All right, my last one. You see my right angle here and my longest side, so this has to be my hypotenuse. My theta is right here, so my opposite side is across from the theta. So opposite across from the theta, which makes this side the adjacent side. All right, nice work. Flip the page over. All right. What is trigonometry? So trigonometry is the study of triangles and the relationships between their sides and the angles between these sides. So trigonometric ratios are related to acute angles of a right triangle, not the right angle. So all these ratios that you're going to learn, sine, cosine, and tangent, those are all related to the acute angles of the right triangle, not the right angle. We cannot use them for the right angle. So I'm sure some of you recognize these words. Sine and cosine are my two fish that are still alive in my fish tank. Poor tangent didn't make it past week 2 of school, RIP tangent. So here are three ratios that we're going to be dealing with, sine, cosine, and tangent. So this right here is a memory device. Sorry, I'm pulling out some highlighters so I can highlight the difference. SOHCAHTOA. SOHCAHTOA. If you can remember that, you can remember the ratios. So sine. Sine is going to be opposite side over hypotenuse. Cosine is going to be adjacent sine over hypotenuse. And tangent is going to be opposite side over adjacent side. All right, if that didn't make much sense, let's go ahead and try some basic problems. So we said that sine uses what two sides? If you look up here for so, it uses the opposite side and the hypotenuse. All right, so sine of theta. Remember, theta is that angle of perspective, right? So they drew my little angle of perspective here. It's saying use angle A. So sine of theta is going to be my opposite side over my hypotenuse, right? Opposite side over hypotenuse. All right, so let's figure this out. Very first step is labeling. I labeled my theta. My hypotenuse is across from the right angle. My opposite is across from theta. And my adjacent is my leftover side right here. All right? So to find sine of A, that's going to be my opposite side, which is A. See this little A? It's going to be my opposite side over my hypotenuse, which is C. My opposite over my hypotenuse. So my ratio for sine of theta is A over C. All right. For sine of B, now my angle of perspective changed. This is my theta. I need to relabel the triangle. So the hypotenuse never changes, right? It's always the longest side. But now my opposite side changes. Opposite is across from theta, adjacent's the last side left. So now I'm doing sine of B, right? Sine is still opposite over hypotenuse. Still my opposite side over my hypotenuse. So it's going to be B over C. We're just getting used to writing these ratios. We'll put numbers into it soon. So we know that sine of theta is going to be opposite. Oh my gosh. Opposite over hypotenuse. Opposite over hypotenuse. All right, now let's move on to cosine. So we said sine was opposite over hypotenuse. Cosine is adjacent over hypotenuse. So again, the hard part is labeling. After that, we're just going to use the ratio. So cosine uses the adjacent side and the hypotenuse. Cosine is not opposite over hypotenuse. Cosine is adjacent over hypotenuse. And ka is what helps me remember that. So, ka, toa. All right, let's figure out what the ratio of cosine of A would be. Well, we know angle A is my theta. Just like up here, I can keep these same labels, right? If A is my theta, that means this is my hypotenuse, this is my opposite side, and this is my adjacent side. The labeling is still the same. The difference is the ratio we're using. Now we want the adjacent side over the hypotenuse. So adjacent over hypotenuse. So my two letters are going to be B over C. B over C. All right, now here, my theta is B, because I'm looking for cosine of B. So I can use my labeling from this triangle up here, right? Hypotenuse, opposite, adjacent. And again, the difference is that we're looking for cosine, right? So we're looking for adjacent and hypotenuse. So it's going to be A over C. A over C. And I'm just using the little labels they gave us, right? Do you guys notice that I circled the sides that I'm using once I figured out which ratio I'm using? That'll be helpful later. Right now we're just slowly walking through all these trig ratios together. All right, tangent, if we go back up here, tangent is abbreviated TOA. Tangent is opposite over adjacent. Tangent uses the opposite side and the adjacent side. All right, so tangent of theta is going to be opposite over adjacent. TOA. All right, let's label our triangles again. Remember, if A is my theta, then my hypotenuse is here, my opposite is over here, and my adjacent is right here. All right, now we're using opposite and adjacent. So what two letters did I circle here? I circled A and B. So tangent of A is going to be A over B. All right, now if my theta changes to B, I've got to change my labels again, right? My hypotenuse never changes, but my opposite side changes based on the theta. And the side that's left is the adjacent. All right, remember we are looking at tangent, so we're looking at opposite over adjacent. So my two letters are going to be B and A, except now we flipped them, right? So everything is based off of the labeling. We need to label correctly, or else our whole problem is going to be messed up and we won't get the correct answer. All right, let's actually put some numbers to these and work out some problems that way. So flip it over. All right. Remember, to find the value of the trig ratios, you need to label. Label, label, label. Label theta based on the problem. Label the sides based on theta. And then you're going to identify the trig ratio based on whatever it is we need. And I'll kind of walk you through that. All right, tangent of z. So it says find the value of tangent of z. So z is my theta. Angle z is my theta. Once I've labeled my theta, that means I can label everything else, right? 35 is my hypotenuse. It's the longest side and it's across from the right angle.
All right, attention again, Banneker family, Banneker teachers, and time.
I paused it so you wouldn't have to hear that announcement. Let's keep on labeling. So across from my theta is my opposite side, right? So this is my opposite side, and the side that's left is my adjacent. All right, so tangent. I'm going to go ahead and write my memory device over here, so TOA. All right, tangent is O and A. So tangent of theta is going to be opposite over adjacent. All right, so now that I've got the tangent trig ratio, I'm going to circle my opposite side and my adjacent side. So here's my opposite side. Here's my adjacent side. So tangent of z is going to equal 21 over 28. Now step 4 says to simplify as well. So on the black calculator, I'm going to hit the fraction key right there and do 21 over 28. It simplifies to 3 over 4. So tangent of z is equal to 3 over 4. All right, let me do one more with you. So cosine of c. Again, very first thing we do is label theta. So c is my theta, so I'm going to put theta right here. Now that I've identified that, I can label all the sides. So this is my hypotenuse. This is my opposite, because it's across from theta, and this is my adjacent. All right, the trig ratio that they gave us was cosine. If I look back up here, cosine is adjacent over hypotenuse. So cosine of theta is adjacent over hypotenuse. So I'm going to circle those two, adjacent, hypotenuse, which makes cosine of c, because that's the angle we're dealing with, c, cosine of c is 16 over 34. That is my ratio. So when I put that in a calculator to simplify, I'm going to get 8 over 17. So cosine of c is equal to 8 over 17. All right, I want you to go ahead and try number 3 and number 4, and then once you do that, start video 2 and we'll check our work.